and welcome to this video on annuities. We're going to cover a problem that concerns an annuity due that is general. We're going to see how to use the calculator to solve this problem. The problem will have two parts, A and B. If you have questions at the end of the video, please write a comment or contact me and I'll be happy to help you. I hope you enjoy. Hi there. In this problem, we have that James wanted to ensure that they had $65,000 for their child's university education. As soon as their child was born, they started saving $1,250 every 6 months in an investment fund. If they achieved their investment target on their child's 19th birthday, and they made no deposits on the child's 19th birthday, calculate the following. First, the nominal interest rate for the investment compounded quarterly. And we need to round the answer to the 2 decimal places. And then calculate the effective interest rate for this investment. And we need to round the answer to 2 decimal places. To solve this problem, we're going to use the calculator. Because we have that payments are or were made every 6 months, and in part A of this problem, we're working with interest compounded quarterly. We have an annuity that is a general annuity. It's not a simple annuity, it's a general annuity because the compounding period is not the same as the payment period. Now, because payments are made at the end of every 6 months, at the beginning, of every 6 months, what we have is that this annuity is an annuity due. So we're working with an annuity due that is general, a general annuity due. And we have the future value of the annuity, which is $65,000. And the original value is just 0. I mean, we start with, I guess, $1,250 because that's what's paid at the beginning of the 6 months. When the child was born, and we're going to figure the nominal interest rate for the investment compounded quarterly and the effective interest rate for the investment. Now, for part A of this problem, to compute the nominal interest rate for the investment compounded quarterly, we take into account the fact that there is a total of 2 payments per year for 17 years. So there is 34 payments in total. So N is equal to 34. We have N equals 34. And to calculate the future value of the annuity, we set the calculator to BGN mode, as this is an annuity due because payments are made at the beginning of each period. So we click on the button second, then we go BGN with your scientific calculator, and then second, and then set, and then we go with second, and then quit. So we have set the calculator to BGN mode. Okay. Then we go with second, and then P over Y, and then the number 2, and then enter. We have just set the 2 to mean that payments are made every 6 months. Okay. Now we go with down, then C over Y, and then the number 4, and then enter, to mean that the interest is going to be compounded quarterly. And then we go with second, and then quit. Okay. Now we want to continue with the following, so let's continue over here. We're going to tell the calculator that the number of payments, the total number of payments is 34. For that, we go with typing in 34 and then pressing the letter N. And then we're starting with 0 money in the fund, or in this case, in the account. So we press 0 and then PV. And then we tell the calculator that payments are payments of $12.50. So we type in $12.50. And then we press on plus minus. And then PMT. Those are the periodic payments. And the final value of the annuity is $65,000. So we type in 65,000. And then we press the button FV for future value of the annuity. Okay. And to find the nominal interest rate for the investment, what we need to do is click on CPT and then I/Y. That's going to give you the value that is the nominal interest rate, which should be something really close to the following number if you have followed along. Now, the value displayed on your calculator may slightly vary from the value above due to intermediate rounding. Now, if we round the answer to 2 decimal places, we get 4.6%. So 4.6% is the nominal interest rate for the investment compounded quarterly. All right. Okay, so this is the answer to part A. And we got to that answer by using the calculator. We started with this line from the left to the right, and we continue with this one, and then this one, and then this one, and this one right here, this one, and the second last one, and then the last line. And the calculator spits out the number about 4.6. Okay. Now regarding part 2 of this problem, we need to compute the effective interest rate for the investment. And that effective interest rate comes from taking the value we just found into account and the number of payments too. Now, so we have that the value right here is found by using a formula. Remember, there's a formula for periodic interest rate when we're working with a general annuity due. We have 1 plus I divided to the m, minus 1. And let's call this I2. That's the effective interest rate for the investment, where I is the periodic interest rate associated with the nominal interest rate. So here I is J divided by 4 in this case, because we are compounding, interest is getting compounded quarterly. So we have 4.6%, in other words, 0.046 divided by 4. And M here is 4 because interest is compounded quarterly. So once again, we have a 4. So we're talking about the effective interest rate being 1 plus whatever 0.046 over 4 is, all that raised to the 4, take away 1. This gives us the number 4.679960 and some other numbers, which can be rounded off to 4.68%. 68, yes. So therefore, the effective interest rate for the investment was 4.68%. If you're using a calculator to work with this number, you want to do bracket 1 plus 0.046 divided by 4, bracket raised to the 4, and then take away 1. Okay, so that's the end of this problem. As I said at the beginning of the video, if you have questions, just let me know. Write a comment or contact me and I'll be happy to help you. Thank you for watching. Bye-bye.